is a stand-up paddleboarder needs to paddle north across a 120-meter wide harbor. The tide is going out, creating a current that flows to the west at 1.5 meters per second. The paddleboarder can paddle at a speed of 3 meters per second. For part A, which direction should she paddle in order to travel straight across the harbor? Part B, how long will it take her to cross? So we focus on part A. We know we have this west current of 1.5 meters per second. If we want to go straight across the harbor, we're going to need to paddle at some angle theta to counteract this west current. So we know that she can paddle at 3 meters per second. And if we see this relation of opposite over hypotenuse, we can use the inverse sine of opposite, 1.5, over hypotenuse, 3. So theta is equal to the inverse sine of 1/2, which is just 30 degrees. Now since we're going north, and then we're saying we're doing 30 degrees east, this 30 degrees would actually be east of north. If you want to write that in another form, you can look at it like this and think about traveling east and then going north 60 degrees, because these two angles are complementary, so they're going to add up to 90. So this would be 60 degrees north of east. So there's your answer for part A. And then part B, how long will it take her to cross? In order to find that answer, we need to find this side, and we can label this A, this B, and this side C. So all we need to do is use the Pythagorean theorem, a squared plus b squared equals c squared. A squared equals 3 squared minus 1.5 squared. So a is equal to the square root 3 squared minus 1.5 squared. You should get about 2.6 meters per second. You're not done here because this is a speed and we want time. So in order to get time, we just take the distance over the speed. We know it's 120 meters. Speed is 2.6 meters per second. So when you divide these, the meters will cancel out, and you'll get the time is equal to about 46.2 seconds. And there's your answer for part B. So thanks for watching, and I hope that helps.